So today a quick video on how to program these accessory decoders. There's two ways of doing it. Either via the programming on the main output of your command station or programming track output. If you use the programming on the main function, this is only used if you've already installed it and you don't need to change any of the other settings inside, just the address. Then you can use that by pressing this button until the LED lights up. You then set the address in programming on the main, and this device will then change to the address that you've chosen. Now, mindful that the addresses that you pick, the address that you set is for output 1. The other 3 will then automatically be set to the following addresses. So if you were to set output 1 to address 1, then this will automatically be 2, 3 and 4 respectively. You could also set it to the next group of 4, so 5, 6, 7 and 8. So just program this device to address number 5. You cannot use an overlap on here, so I couldn't program this to 3, 4, 5 and 6 because it's always groups of 4. So keep that in mind when you're setting these up. Now, as I said, that's basically only if you want to set them up just by changing the address and you're happy with the default setting. Now, the default setting of the outputs of these modules is a momentary pulse signal, so that'd be good enough for, let's say, driving a point motor that is has these solenoid coils, this click clack sort of action. That means that the pulse on the outputs are only temporarily live. If you're using other types of drives, let's say a slow motion motor or stall current motor, you need the output to be live a bit longer for the time, to give it enough time to turn the point. Now, for that you need to get into the registers of this device. There are some registers where you can change the behavior of each output, and the first 15 registers, registers 1 through, of values I should say, in the output registers. The first 15 determine the length of the pulse. You can set this from a few tenths of a second all the way up to several seconds. And there is a setting also for permanently on. Those types of settings, permanently on for example, is good if you control a light signal with this device. Obviously you want the light to be on all the whole time, so it just needs to change state from red to green or vice versa, for example. That's when you use the set point of always on. And then there are some special functions to make an output flash, let's say a grade crossing or things like that, but that's I won't do. I'm just going to set this up now for use in my slow motion point motors, and for that for that reason I need to change the behavior of the outputs as well. So first off, I'm going to set the address of the decoder, and for that we're going to use the command station remote. So let me just power that on. There we are. We're going to go to programming on the main, and that is in function menu 8 in a Lenz system. So F8 programming. Now we just have to scroll to register. There we are. Enter. Now the first register is register number 1, and in that we're gonna enter the address that I want my first output to be, in this case 5. So I'm gonna enter a value of 5 and enter again. It's programming. You saw briefly a P in the bottom left corner, and now I'm getting an error description. This is normal. The error is there because there is no load connected to the module. If it was already a load connected like a motor, the error would not come back and it would give you a message that the programming was successful. So disregard that. So press clear, go one step back. I'm now having to set the behavior of all 4 outputs, and these can be done individually. So you could do 2 outputs as default, but you could also do the outputs, one output as permanently on, and so on. So those are registers 2, 3, 4 and 5, corresponding to output 1, 2, 3 and 4 respectively. So let's first go to register 2. Step 1, register 2, value. Now I'm going to enter a value of 10, which in a table in the manual corresponds to 4 seconds. So there's the error message again telling me it was actioned. One step back and another step back. Sorry, escape, yeah, register 3, value 10, the briefly flashes and the error messages back up. Okay, back again, enter output 4, value 10, and watch the screen again. The P should briefly flash up, there it is, and followed by an error. Again, a signal that the address was set properly. Lastly, number 5. 5, enter value of 10, program, and done. So I've now set all 4 outputs to a function for a slow motion action motor, and each output will be live for about 4 seconds, which is enough time for the point to move from one position to the other. So now we need to install it. So following on from the programming of the accessory modules that I showed you before, the LS100, I'm using the LRB08s, which is one of the newer modules made by Lenz for the occupancy detection on the layout. They are based on current detection, so basically one of the inputs, once there's a locomotive or anything else that draws a current, like a wagon with interior lighting, for example, once there's a current detection on the section of track that this one is connected to, output 1 is connected to, then a feedback signal is given to the DCC system saying that that section is occupied. So if you divide your layout in sections and you move 2 adjacent pieces of track, connect 2 adjacent pieces of track to these, the first 2 outputs, when a locomotive enters from section 1 into 2, the detection will be fed back to the system. As you know, or maybe not, this is a reminder then, I'm intending to at least have some feedback on a computer screen for the layout, particularly important for my hidden storage yards, so I can actually see which tracks are occupied and maybe also by what, because I can't see them anymore. So some feedback is important, and you know, moving on from there, you could possibly consider doing some automation. And to a degree, I'm kind of contemplating with the idea to automate the passenger trains, because they tend to run on a stricter timetable that run between the 2 stations eventually, and manually drive the freight trains and the shunting duties and things like that. So there's always something happening on the layout while I'm fiddling around with a freight train or setting out some cars and things like that. So onto the programming bit. Let's put this thing down. I've connected it to the programming outputs of my DCC system. Set the system again into programming mode and opted for CV. The LRB08 needs to be programmed using CVs, where the LS100 uses registers. The principle is the same, however. So you just select CV in your menu system, press enter, say what CV you want to program. CV1 is the address section, enter, and now give that a value. Now the Lenz system recommends that you program your feedback modules with addresses 65 and upwards. So the first 64 are mainly reserved for accessory decoders. So if you have accessory decoders like the LS100 with 4 outputs each, that means they've got 256 outputs available for switching turnouts. For most people that's more than enough. So address the modules for feedback from 65 upwards. I already fitted one in the storage yard called Warfum, so that's address 65, and this next one is going to be address 66. So I'm going to enter 66. There we go, and enter programming, and it's giving me a reading that 66 is set. Now the address numbers of all the outputs are now numbered 66-1, 66-2, etc. all the way to -8. That's how you could number them. Now there's another setting you could do, which is detection delay, and they have a range as well, which is in milliseconds. Basically you set the sensitivity of the inputs there. You could leave it as it is. I tend to increase them a little bit to avoid spurious inputs, so that is CV40. Go back one. Okay, so CV40. All this is in the manual. And give it a value. Now the value ranges from 0.01, which is 10 milliseconds, to 2.55 seconds, is 2555 milliseconds. Half a second is for me is enough, so that would be a value of 500. So I'm going to enter 500 and enter. Now all inputs have half a second delay before they give me feedback, and that's enough. More than enough. As I said, the factory settings I think are only a few milliseconds, but that is more than enough. Now if for some reason you've already installed the module and you haven't programmed it yet, you could still change the address. The way that's done is with the manual push button here on the bottom, which will then mean a light comes on, and then using programming on the main you can just change the address by changing CV1. But I would suggest do the programming of the modules before you actually fit them, and then things make it a bit more easier. And you can do it by a desk if you wanted to. So much for feedback modules. So we've done an accessory module and now a feedback module, and that's all we want to do in regards to digital control for now. So see you in the next video.